Good afternoon. My name is Arjun, and I'm the founder of Shoestring Software. We are making a series of videos on Rust coding, and the first video we are going to make a JSON parser using a parser combinator library. Now, if you want to know what is a parser combinator library is a way to build complex parsers using by combining smaller parsers, and you can read more about it here. Almost every language has a parser combinator library, and we are going to use this library called norm in Rust to build our JSON parser. The motivation for this video came from this video, very popular dev channel. Here JSON parser is made in Haskell from scratch in about 111 lines of code, and we're able to do the same in Rust. Rust is not only a very powerful and safe language, it's a very productive language. It's a joy to programming. I know a lot of people have apprehensions about ownership, borrowing, and all those kind of things. But once you get into Rust and you start understanding, all these things will be will not even matter, and you will see that how productive Rust is. And having programmed in Clojure and Scala for more than a decade, I can tell you I miss nothing, and I have the same kind of productivity. And in fact, we will run two videos. One is Rust for Clojure developers, Clojure and Scala developers, and another one is going to be Rust for scripting. I know many of you would say, okay, what next, Arjun? Scripting using assembly, because Rust is a systems programming language. Rust is a fantastic general purpose language. Okay, let's get started with writing our parser. So we'll make a new project. We have new project. So cargo new JSON demo, and cd JSON demo. Let us. I have some aliases, save me a lot of time, so let me just put them in. I don't put them in my RC files because my RC file will become humongous. Okay, all right. So let's start NeoVim, and all right. Let's change the hello world message to Rust rocks, and let's also add norm, create the norm library to our project. So cargo add norm. Okay, and so then let's run the code. Okay, Rust rocks. Why not? Couple of exclamations. All right. Okay. We are set. I do this when I develop, when I code, because I don't like too much of squigglies around and too much of warnings. Once I have written the code, I can remove this, but all the unused warning then go away. Oops. Okay. Let's see. All right. Okay. So what did I do? I did the wrong thing. Sorry. Oops. All right, let's get the imports. So let's go to the documentation of norm. And in norm, the two most important types are, one is parser. Okay, parser, and that's the one. Okay, and the parser has a parse method where we'll give it we'll give some input, and we'll get an I result. So I result is the second most important type, and I result is parameterized by three types: input type, an output type, and error type. We'll not focus a lot on the error type. The input type is going to be string slice, and the output type is going to be the structure that we choose. So you can see what I result is. It's like this, and it's nothing but an alias on the standard result. Basically, the success type is a tuple of input and output. This input is the trailing string. So when you parse, you have a string, you have a file, you have a lexical unit, and the parser keeps parsing incrementally, and whatever is left not parsed by the specific parser, because in parser combinators, we are combining small parsers, like for example parser digit. So something parses a digit, and then the rest of the string is there. That rest of the string is the I part, and the O is the integer or float. I mean, it could be any of the numeric types. That's the O part. Okay, so let's then get these guys in. Alrighty. So let's write the AST for the JSON parser. So JSON has these kind of types, and when we parse a text, we convert it into a data structure, and the data structure can be used for like compiling to assembly, executing code, or in case of JSON, going through the data and consuming the data in the right structure, right? Because we have converted the text into proper data types. So let's start with this. What are the various kinds of JSON value? So let's call it AST enum. We'll call it JSON value, and first is JSON null. So JSON has the word for null. The $1 billion mistake. Yeah. And by the way, Rust does not have nulls, safe Rust. So Okay, then we have the boolean. So we have JSON bool, and that should give us the bool type, true or false. Then we have a JSON number. And now what do we want the number to be of type? It could be, like JavaScript has just floats, 64-bit floats, but we will have both support for integers as well as floats. So what we'll do is that we'll create a type called numeric, and one of the variants will be integer, which will have a 64-bit integer, and we'll have a float, which will have a 64-bit float. Okay. Let's derive some traits for our types, useful ones. Okay, so now we have JSON number and we'll have numeric. Okay, all right. Then we have JSON string, and that should have the string value. And then we have a JSON array, which will be a vector of JSON value. And then we'll have a JSON object that will be a vector of tuple of string and JSON value. Okay, so all right. Okay, so I think our AST is done, and we will start making our small parsers for each of these types. So let's start with null, and call parse JSON. Now parse null, and the input will be a string slice of this parser, and the output would be a result, and the result will be string slice, and we don't want to consume the we don't want to transform null into any type. It's null, so we'll just put a unit here, which we'll discard. So how are we going to do that? So in you have a lot of combinators here, so we'll use a couple of combinators here. The first combinator is called tag. It's the most important. By the way, you'll see this bytes complete, forget about the bits, bytes complete tag and byte streaming tag. I use the complete version because we're not making a streaming parser. So we'll use this one. So tag. A tag is used to parse a literal. So for example, here it says tag hello, and it parses hello. So we are going to parse null. So by the way, when we parse null, now if you look at it, it actually, if you see here, parser hello world, what is the output of it? It's going to be, the result is going to be the trailing, the unconsumed input and the value. In our case, we want a unit type. We don't want this code and the rest of the unconsumed input. So there is another function called value, and that's here. And what does value do? Value takes a child parser and gives you a value. Okay, so what we're going to do, we're going to say value value is going to be unit type, and the parser is going to be tag. Oops, so many parsers. Tag, because there are many parsers. They tag bits, they tag bytes, and you know, let's just get that tag stuff in from here. I get so many tags. That's the one. Norm bytes complete tag. Okay. All right. So use tag. And we'll say tag null. Okay, and then we will say parse I. Okay, this compiles, so you can check, you know, so it's compiling. By the way, people talk a lot about the speed of Rust compiler, you know, so while you're coding, you just don't need to run your code all the time, you know, and so you can use cargo check, and that's blitzkrieg, so there isn't any issue there. Okay, now let's test this. Okay, so you write test functions, we write test functions right below the function under test. I will call it test null, and we'll do our test, and we'll say parse null, null, and this should be is okay. So let's run the test, and our test is running. Test null is okay. Okay. You know, you might think that, you know, if what will happen if you run this. So let's run this. Now you'll be surprised that this is also going to pass, and you would be saying, well, null is, and it is not null is it's not null, the string. So the part is that in our driving parser we will have something which is going to ensure that if null is a part of a string, then it's going to fit. So we can test that here itself. There is a function called yeah. So we can. It takes a child parser here, so we can do one thing. We can write all consuming. Thankfully there's only one all consuming. We can say parse null, and then we can say parse, and then we can say null is, and let's see if that helps. Is okay. Now this should not be okay actually, but let's see what happens. So our test has failed. So this portion that we have, this is going to be in our driving parser, because we don't want to write all consuming parse null, all consuming parse bool, all consuming parse number. So if you want to test this null as a part of another larger string, then you can use this approach, and to make this test pass, you have to say it's error, and now our test is running. Okay. All right. So let's go to bool. Next is bool. So let's write function parse bool. Again, input is string slice. Bool. Result is going to be the trailing input, and now we want the value. We want a boolean value, okay, which is going to be used in the program which consumes the JSON. Okay, so let's write it. How are we going to write this? So a boolean can be true or false. So let's write that. So either true or false. We need two parsers, and we need to combine them using something called alt. If you see alt, what's alt? Yeah. So alt, no, this is not the one. Is this the one? Okay. So it accepts a bunch of parsers in a tuple, and it tries them one by one until one succeeds, until the one of them succeeds. So let's make a boolean parser. So we'll write, and by the way, whatever the boolean parser gives, that's going to be the value. So the value is going to be a bool type. It's not going to be a string true. It's going to be a bool true. So let's write a true parser. Let's call it true p, and true p is value what? Value true. And we call it tag true. Don't you think Rust is so beautiful, so enjoyable? Are you feeling scared of Rust? It's actually one of the most beautiful language, but that's my view. Beauty lies in the eyes of the beholder. Okay. Nothing against any other language. I am, I've used so many languages, and I've learned so many languages which I haven't used. Haskell is my, it's a regret. But then I have a plan for Haskell to in future, but that's future. Okay, we have a true parser. We have a false parser. And if you know that this is also a parser, this combinator value is going to produce a parser, and now we are going to use the alt with a tuple of n tuple of parser. So let's try true p and false p. Alt. Parse. Okay, this compiles. See, that's the magic speed of compilation, right? All right, so let's test this. So we are not going to do this all-consuming part. So if like tomorrow we have true is, we don't do that. It's going to work. Test bool, and test bool is assert parse pool true. Now we can write it as is okay, but there's a if you want to write it using assert eq, it's like more cumbersome. Let's write it this way first, and this should pass, and let's run the test, and the two tests are passing. I like it when I see OK and OK. Sometimes I've had a horrendous experience when nothing is working, right? So it's a pleasure actually to see that. Okay, and let's write this also false, and now this is also working. Now you can write it like this also. You can write assert eq parse pool true is okay. True. Okay, so that also works. But we'll use is okay and is error. By the way, we are not converting this into the JSON values as of yet. We can write a function, and we can write a function. Okay, we can write a function. What is the function we can write? Okay. Function parse JSON. We'll write two functions, a driver function and a child function, let's say. And that is going to be. You can look at Soding's the channel's video. This one, it's pretty heavy actually. It's Haskell, and you might get lost in the video. But I'm using similar techniques thanks to Domtrade. So we have the same compactness also. All right. Result. JSON value. Now, what is going to be a JSON value? So a JSON value, you can get a string like this. Alright, so it could be something like this, and there could be so many new lines, empty spaces before the object, and then you might have something like a 1, 2, 3, and the white space all around. So we want to remove these white space, the prefix and the suffix ones, the trailing ones, the one before. So we should write a parser again, which should be able to do that. So there is something called delimited combinator. Thank goodness for one. It takes 3 parsers, it parses the 3 successfully, throws away the first and third, and gives the value of the second. So this is perfect for us. Okay. So let's write delimited, and we want space. So space. We have multi-space, multiple spaces. This is the one we want. Okay, norm character complete multi-space. There are too many multi-spaces, and the NeoMim assistance is going to show me a bunch of them, and I'm going to get confused. So let me just write the import. So let's write US num. So this is multi-space, 0 or more spaces. Okay, so let's go back and let's remove this. Alright, so we will write multi-space, zero. The second one is we'll write the second one in a minute. Third one is also going to be multiple spaces. So let's write multi-space. Okay, and this looks good. Now we have to write so this is going to be alt again. Oops. And what are we going to do? So we have written boolean null. So let's say we will write map, something called map. It's another combinator. Map. Yeah. This one. Norm combinator map. Okay. Okay. So we'll say map, and then we're going to have parse null, and map takes a parser and a closure. Okay, we don't bother about the unit type, we just get the JSON value. So this is going to be okay. Why does it say yes? Oh yeah. So we say JSON value star. Okay. It's too many. Let's see if we can get these. There you go. Okay, so yeah, it compiles. Okay, so let's write the other parser. We have parse bool, and that is going to get a boolean value, and we are going to create a JSON bool with that v. That's nice. Okay. So now the driver function would be like this. So we're going to keep, as we keep adding our parsers, as we keep writing our parsers, we'll keep adding them here, okay, to get the actual JSON value. So now we'll say parse JSON. This is the driver. and I talked about all consuming and JSON value. Okay. JSON value, and what are we going to do? Okay, so we're going to write all consuming parser JSON v dot input parse I, and that is going to be, so it compiles. Yes, it does. It compiles. Okay, so now we can just test it. Okay, we can test it. We can test it, and test JSON, and let's say we say insert parse JSON none. It's okay. And let's run this, and it's running. If we write this, null is good, null is bad. And it fails. So we should write, this should give an error, and that's how it is. Okay, we can get back to, we have the driver, we have written two parsers, and then, so we are now going to write the number part. Shall we take a break? Is there anything called pause recording? No? Stop recording? Okay, we'll keep going. Okay, we will stitch up two videos actually required. Okay, let's go with numbers. Parse number. Parse number. Actually, this is the easiest one to write. Not only because of norm, but because of Rust too. I told you Rust is a beautiful language. Okay. So what are we going to use? So there is a combinator called recognize float. Yeah, that's the one. This norm. So let's do this. Recognize float. All right. So what are we going to do now? This is going to be a little different. We are going to evaluate a few things and actually give back I result. So let's write that. Let I, now let's call it num string is equal to recognize float. And yeah, okay. And are we getting something? Yes. Okay, and then we can write this, or call something as the value is if num_str contains decimal or num_str contains e. Sorry for writing it like this. I could have used a set and say contains particular like that, but okay, we'll keep it simple and stupid, as they say. Right. If it contains these things, it's a float. So what we're going to do is we're going to say hold on, numeric integer, sorry, numeric float num_str parse, else we will have numeric integer num_str parse. Oh, what are we saying? Expected type float 64. Oh yeah. Okay. So for the purpose of this video, I'm going to take a shortcut, but this is a result type, and we have to map it to the iResult type. So if you really look at it, the result type from parse is some different kind of a error. Well, let's try it. If I do this, what happens? No. So there is a mismatch. The expected error type is norm error, too many errors. Okay, so we'll not do this. Okay, for this one. It's very easy actually. Once you know Rust, just you do a map error and you can convert it into a norm error, and that will take care. But and then you use the question mark operator, like here. Note this is not an introductory course in Rust, so I expect that you know a little bit of Rust. But essentially, it unpacks the result, the value inside the result. If it's okay, and gives you the result, and it's an error type, because result is like a jailbreak data type. It's got two choices: success, failure. So that's how it is. If it's a success, it unpacks the value, right? So let's just write this unwrap, and let's write this unwrap. Okay, looks good. And now we say I and we. Remember, iResult is the type alias to the standard result, whereby the success type is the tuple of the trailing input and the value that is passed. Okay, so we are doing good, and let's check everything is fine. So you can see it in November. you know. Sure is. Okay, test number, let's test it. So this is classic, unit testing, and Rust makes it so nice. You can write your function, you can write the test right below. I liked the Python doc test, whereby you can just keep writing your cases, or just copy it from the console, and the test is taking care of it. I don't like cumbersome testing frameworks, TDD frameworks, and so this is pretty nice in Rust. Okay, let's write. Let's actually write the assert EQ version of it. Okay, so if we say parse number 1, 2, 3, we should get what? We should get tuple, empty string, and 1, 2, 3. No. Says what? Oh yeah, sorry. Expected numeric. Okay. So, well, let's use numeric. We should get integer 1, 2, 3. Okay. Let's see if it works or not. Let's test. CT. Okay, it's running. All test pass. Let's do a floating point, and okay, float. This is actually, I don't know, it's going to compare or not, because floats are not supposed to compare, but it might compare. Yeah, it's okay. All right. So we are done with the number, and now we are going to do string. Now, if you look at Soding's video, he uses very simple string parsing. No fancy Unicode, escape sequences. I don't think it's there. It's not there, as far as I know. It's not there, 100%. So we'll have a little bit of escape sequence, because we are using norm, and it's so easy to write a fairly good implementation of string literal. So let's start. Parse string. We're going to give string type. In Rust, you will hear there are different kind of things: a slice, and a heap allocated string. They're all basically bytes of valid Unicode bytes. In I don't know, we should put UA 32. I don't know. Rust string. Rust string. Utifate. Sorry. Utifate. Okay. Utifate. Yeah. Utifate encoding. So, right. So they are all UTF-8 encoded. Okay. Yeah. Okay. Sorry for that. Sometimes the Rust types U8, UTF-8, just keeps hitting, so, all right. You can learn about it. It's a pretty simple concept. what is UTF-8 encoding, what is string encoding, so both slice and string at the end of the day are a collection of bytes which are encoded as per UTF-8. Okay, and that's one of the reasons why you cannot index a string. Like you cannot say I1. Well, it's a bunch of bytes, and the first character might be multi-bytes. So, the first byte, that is the second byte, index 1, might still be part of the first character. Okay, so a little bit of a detour on Rust strings, but that's good. Let's get going. So, what is going to be a string? Okay, so what is going to be a string? Right, and so what are the characters? So valid characters are going to be anything apart from quotes, backslash. These are going to be escaped, okay, and control characters. So we should first write a function called this normal char. And this is a predicate, and C is not equal to what? Backslash and C is not equal to backslash is not equal to quotes, and C is not a control character. That means basically anything greater than equal to less than 20 is a control character. So that is going to be a normal character. Okay, all right. So what is a string? A string consists of sequence of normal characters and can have escape sequences and can be an empty string. Okay, so first we are going to do we're going to write a normal sequence. So should we write separate function? Should we write it here? Okay, let's write it here. Let normal parser is equal to produce map, because we need to produce some values. Which is string, another string slice. So what is going to be the parser? So let us go back. So we're going to take while. So there's going to be something called take while 1. So it's this one. Norm bytes complete. Okay. Norm take while 1. Now we are going to say take while 1 and take while 1 actually takes a predicate, as we can see here, condition. Okay, condition. Okay, so what is the condition? Is normal tab. Okay, and then we should convert this to a string. Okay. Okay. All right. So we say S to string. Okay, and this is our normal. Take while one. What is wrong? No break. Type annotation is needed. Let normal parser take while one. Take while one is normal character. Yeah. Okay. Okay. What is the issue? What is the issue here? Take while one. What is the issue? Is this complete? Yeah. What about this one? Non-bytes. Non-bytes. Okay. The same stuff. What happened? The reason. Output is string. Implementation. Okay. Multiple is satisfying. Multiple. Okay. All right. Okay. Okay. Let's see what happens. Let's take a break. Why this is happening? Okay. Yes. Take while. What is wrong with this? Take while. Take while. Now by take while one. Now by not streaming. Let's not have this. Take while one. Now by complete. Complete. Now by. Okay, let's see what happened. Is cannot infer tag with the parameter error. Oh, take while one. Okay, cannot infer. Parser required this one. Take while one. Okay, all right. All right, let's see if I do this, take while one. Is normal character. It does not take it. Okay. We'll see what we can do. Okay, we are stuck, but this is not really a problem. Okay, let's keep going. Okay, take while requires it cannot infer the type parameter error. Okay, we can handle that. So let's first do the string body. The string body will have normal characters. It's going to have escape sequence. So we'll write the escape sequence. Before that, let's complete the string parser. So let's call this let body p is equal to okay, all right, map. Now we might have many sequences of normal characters interspersed with escape sequences. So we have to run this normal p and the escape parser that we'll write, escape sequence parser, multiple times. So we have to use another combinator, and that's called many zero. Yeah, many zero. Okay. Okay, so we'll write many zero, and it takes a child parser. And what is going to be our child parser? It's going to be a alt of normal p and it is going to be the escape p, which we have not written. So, and then we will have a vector of strings, and that will be, that has to be concatenated. So let's write v. I can see that v is a vector of string, and so we can say v concat, and that is the body parser. And finally, the string parser will be delimited char, char. I call it char, but because we pronounce character, but sometimes we call char as char, but I have a habit of calling it char. So let's see char. Again, too many chars. Too many chars. This is the char we want. Norm character complete. no character. Okay, we have it complete. We have it there. We have used char. Okay, char this. As you know, delimited has three parsers, three child parsers, and it matches all of them in sequence and just gives you the value of the second parser. And that is exactly what we will use for our string letter. So we'll say char. Okay, and this is going to be body p, and now this, and our error is gone. Okay, so now we need the escape parser. The escape are preceded with a backslash. We'll not give support for everything. We'll give support for slash, quotes, new line, carriage return, and tabs, NRT. Okay. In fact, with the sorting code, we did not have any escape sequence handled also. So, but we'll do that so easy now. So, let's do that. Let's write let escape p, escape parser is map, and the combinator we want is called preceded. Yeah, this one preceded. Okay, so life is good. So preceded matches the object, the first parser discards it, and then gets an object from the second parser. So let's do that. Let's do that. Preceded. What is the first parser? Okay, so we are going to do char, and the second one would be an alt. It could be any of the escape sequences. So let's write it like this. I know it's a little bit dirty and I don't want to format it right now, but let's do it. Yeah. And what are we going to have? So we want to give the actual string because we have a string from our normal parser. We want a string from escape parser also. So first we'll do this one, value, and we want a char. What char we want? We want a backslash. So this is like writing double backslash in your string literally. You want a slash, that's backslash, you write it like that, okay? Like this. Right? Oops. Alright. Okay, so value, char, this is okay, escape, and now this should compile completely. We should say str as to string. Do we need to do that? It's already string. No, it's a string slice. We need a string. Okay, we need to do that. Okay. No errors as of now. Good news. No news is good news. And this is nice. Okay. So we have, this is pretty good. So let's run this. Yep, it compiles. And okay. So now we need quote /n /r and /t. Okay, y, and we need 4 of them. Yeah, the path, 4, paste. Okay. Okay, then we have N, we have R, we have T, and we have N, R, and T. Okay. This looks like the complete string parser. So let's test it. So let's call it test string, and we are going to say assert parse string. So the string is going to have quotes. So let's write so string is going to have quotes, and let's say hi there, and this should be oops. Let's run. Great. This is parsing, so let's write another test. We'll put in some escape sequences. So we'll say line 1, line 2. This should also parse, and no, it failed. What is wrong? What is wrong? Why is this not parsing? Okay. Oh yeah. Oh yeah. Oh yeah. We have to give actually /n, because this is becoming a part of the Rust string. So we have to give this, and then it works. Okay, now it should work. CT. Okay, there. We are back in business, so we can write this in a much better way, probably. Let's use the raw string and see if this works or not. Raw string. Okay, if we give something like Okay, so we have this is a problem with the new vim thing. So we have a string, and inside this is the Rust part. Okay, first and last. This is the string which is going into our parser. So, okay, what is? We write line 1/n, line 2. Is this going to work? Is it okay? Okay, let's run it. Perfect. So we are done with the string. Since we are done with string and numbers, we did not add them like in the Haskell video. The author was continuously writing and adding it to the main parser. So let's write it because we need the JSON value. At the end of the day, we don't need the wrapped up values, okay, as per our AST. So we'll write map parse number and value is numeric. So value is numeric, yeah. JSON number v, and then we have map parse string v JSON string v. This is looking good and this is good. Okay, everything running, all the tests are running. Now we are entering the array part. Again, you will see parser combinators make life very easy. So we'll have arrays. Array can be written like 1, 2, 3, and you can have spaces at anywhere. It can be like this, it can be like that. It could be this way, and it could be like this. So all these combinations have to be taken care of. So how are we going to do this? Okay. All right, let's write it. Parse array, and what are we going to do? A result, and we are going to give a vector. Okay, so we need a vector of JSON value here directly. Okay, so good. And we're looking good actually at this point of time. So what is going to be the parse array going to do? Now remember, if the string has spaces before the bracket, that's going to be consumed by this parser. So we are not really bothered about it. We are bothered about this kind of input, okay? The string should be, we can assume that the string starts with a bracket and then it can have 0 no white spaces. So, and then we have a trailing we have trailing brackets, and the brackets can be Trailing bracket can be, preceded with spaces. Okay. All right. So looks like we have to use delimited, and then we have to use a combination of we need a combinator that's going to take the bracket and spaces and the spaces and the trailing bracket, and in the middle are the values separated by comma. Okay, let's start. Delimited. Now here we are going to use a combinator called pair. Thankfully one pair. So it takes two parsers, gets an object from the first parser, then gets the object from the second parser. Perfect. That's what we need. Okay, so we'll use pair. What is the first parser is going to be like? So the first parser is going to be char bracket, and the second parser is going to be multi-space 0, our old friend. So this is the first parser. And the third parser is going to have the opposite order. So we're going to say pair. So we're going to say multi-space 0 and char. This looks good. Okay. So yeah. Okay. This looks good. So now what is going to be the middle? That's the meat, right? And it's the middle values that we need to get, right? So how are we going to get that middle value? So we have a separator, we have a comma, and the comma can have spaces in any amount, no spaces. You could have 5, 6, you could have 7. Okay, so all right. Okay, so what we need is actually another combinator. Separated list. You could have an empty separated list 0. So this is non-multi. So what does this take? It takes a parser which represents the separator, and it takes a parser which represents the value. So it automatically parses a bunch of values separated by another parser, another value. So let's do this. Let's write this. We say separated list. No, I need 0. There you go. So this requires, what does it require? What is the, remember JSON value already has a parser which is going to eat the starting spaces. So all we need to do is the separator should be 0 or more of spaces followed by comma. That is going to be the, okay, let's see. Oops. So we're going to use pair again, and we're going to have multi-space 0, and then we can have char comma. Okay, this is the separator parser. And what is the value parser? Well, we already have it, it's right below, which is this one. So we have to say JSON value. So this is going to take 0 more characters, ending with comma, and then parse JSON value. This is the this should be the hold on, what happened? Yeah, this should be the, okay, we can just write it down like this. All right, looks okay. Meter. All right, so we have bracket with 0 more spaces, and then we have separator which is 0 more spaces and comma. Then we have a JSON value, and then we have multiples of them, and after that we have 0 more spaces and bracket. So this should be the right thing, and we should write parse I, and this is the Parsec. So at least compiles, and let's write the test array. Okay, so assert parse array, and we should have an empty array, which should be okay. And CT, and the array is running. Perfect. All the tests are running. You can see the test here. Okay, and now let's make something like this, and this also runs. Let's do something like this. This is also running. Let's do something like this, and this is the dirtiest of it, and this also runs. Perfect. So we are now down to our last parser, which is the object parser, and you can see how simple and how neat, once you know how to combine, the parser looks. And this is recursive, this is nested, so you can't you can't do it with regex, maybe with a lot of tricks, but I guess you wouldn't attempt that. So so let's now add this parser. It's a map parse array we JSON value, so we can say JSON array v. Okay, all the tests are running, and now we have our array. Okay, now let's have some tea and go for the final parser, which is the object parser. So object parser in some sense is just like it's just like the array parser. The only thing is that you can think of it as the starting and the ending character are braces instead of brackets, and you still have commas as separator, but you have now key value pairs, and the key values are actually two values. One is a string and one is a JSON value. Okay, that is what is the okay. All right, let's all right. So we are going to write the key value first, and then we will write the parse object, because parse object is going to be similar to parse array after we have the key value. Okay, so let's start. Parse key value. I result. And this is going to give a tuple of string and JSON value. So, so the first thing we need is the string. Then we need we need the key value is going to be like this. Key value is going to be like k and then colon v. So we can have any combination. It can be like that, like this, anything. Okay. So the first part is a string. So this we're going to write it in a more elaborate fashion. So we're going to say that I and let's say that k is parse string. We've already written parse string. So I. So we have the string. Then we need the colon, the value which we can ignore, so it will be delimited. What is going to be the first one? The first one is going to be multispace. Multispace. Second one is going to be char colon. Third one is going to be multispace. So we now have Okay. Okay. Right. And I think we don't need this because JSON value is going to work. Nevertheless, let's keep it. Let IV is parse JSON value I. Okay. Oh no. What did you do wrong? Okay, that's it. We didn't do anything wrong. No. Okay, that's it. So, what are we going to send? We are going to send tuple of I and then tuple of K and V. Okay. What happened? Oh yeah. Oh yeah. Okay. All right. This looks like good. So shall we test this? That's key value. Okay. Function test key value, and in this we will say assert parse key value. Let's call it ABC colon 1 is okay. Let's run it. Okay, key value is okay. All right, now I think the object is going to be very easy. So let's write parse object. Result. This is going to be a vec of string and JSON value. So this is going to be pretty easy. Just like so we're going to have a place and multiple thing. Brace started with a list of values, okay, and the list of values is going to be separated comma with spaces around, and also the value. Okay. Delimited. We can say pair, char braces and multi-space 0. That's the first one. Oh, what happened? Sorry. Third is going to be pair char, but this is going to be multi-space. Okay, so multi-space, and this is going to be our separated list. Separated list, so separator and the parser. Okay, so we're going to have separated list 0. Okay, and so what is going to be the separator parser? So that's going to be easy, delimited, multi-space, this is going to be multi-space 2, and so after the key value you can have space and comma, and you have to eat up the space after the comma too, because we are going to use parse key value, and if you see parse key value does not eat up any string, white space, that is in the beginning, so we need this one, and the second one will be simple. Okay. I think this should be it. Oh yeah. Oh, no error. Too good to be true. Okay. Let's try it out. Test function, test object. Alright, so this is going to be test object is going to be assert parse object. What are you going to parse? Okay, let's write object, call it payload, and okay, we have it, right? Okay, parse object, yeah, all right. So let's write name Linus Torvalds. Okay. Age. I don't know Linus. I can check it out, but let's call it 55. Let's say it's 55. Okay, now Genius stud through how many followers? Maybe 100, maybe 1,000, 10,000, maybe some more thousand. I don't know, fits in. Okay. Payload is okay. All right. Let's see whether this is parsed or not. Because this has to parse everything: Boolean, integer, array, everything, string. Oops. Success. Bingo. Okay. Let's celebrate by having tea. I started this video. Oops. I started this video just before evening, late afternoon, and finished it right now. Early evening, and now. So, okay. So we're done. And all we need to do is we have to say map parse object parse object JSON object v. Hopefully this v is Where did this come from? Okay. We are done. We can test JSON. We'll be lazy and we'll put something here. Let's say payload. And let's assert parse JSON. Okay. And now we can do this. And we can say payload is okay. That's it. It's working. Let's another field. That's the address. It's going to be a hash. And house. 1, 2, 3. street, the next way, one the next way. Okay. Alright, so let's run this again. Great, it's working. And so we have decent JSON parser. So I hope you enjoyed this video. By the way, let's see how many lines did we take compared to Haskell. Okay, so let's put all the tests. Here, okay, so we will, let's say, let's call it test. Okay. Right, so parse pool. Number, string, parse array, parse key value, and parse object. Okay, parse JSON value, parse JSON, and this is the last test which we are going to remove, and okay. 117 lines, so Rust rocks, and we matched 111 lines of Haskell with 117 lines of Rust. All right, have a good day, and we'll come back to you with more videos of Rust and how we can do crazy stuff with Rust. We'll show you scripting with Rust, we'll show you functional programming with Rust, and Clojure and Scala guys, stay tuned for our next videos. Bye bye, have a good night.